Hi, I am Ganesan and I finished my Masters in Product Design and Manufacturing. Now we are going to discuss about air vehicle propulsion in aircraft engine. Entering into the air vehicle propulsion system, first we need to know what is a propulsion system and what are the components which is being involved in a propulsion system and what are the design considerations we have to consider in order to get a maximum efficiency or maximum power in a propulsion system so that it will be helpful in better thrust. So first entering into the air vehicle propulsion system. First we need to know what is a propulsion. Propulsion is a force which leads to a motion. In the sense, propulsion is created with respect to the force which has been created in a propulsion system with respect to the rotation force of the propeller or the fan which has been subjected or which has been connected to the engine part of the aircraft engine, and with the help of the propeller the air is being sucked inside, and this air helps us in creating a motion to the aircraft which helps us in moving the aircraft in the forward direction, that is known as the thrust. Here, what are the components and what are the design considerations which we have to consider in order to design or in order to manufacturing a propulsion system will be discussed here. First, what is the mechanism which is being involved in an air propulsion system? Here, the line diagram of an air vehicle propulsion is being drawn here. Here, the first one is the inlet deck where the fan or the propeller is being subjected or situated, which is being connected through a compressor with respect to the shaft, and after the compressor it is being connected to the combustion chamber, and after the combustion chamber it is being subjected to the turbine, and from the turbine it is being subjected to the nozzle. Here we are going to discuss about each and every design as well as what are the functions of these components with respect to the propulsion system. The first engine was being developed by Dr. Hans Swan and Sir Franklin Whitehead. Now, what is the function of each of the component which is being situated in the air propulsion system? The intake duct, which is known as which contains the fan or the propeller at this area. The air which is flowing inside the nasal structure, that is the air which is the air which is coming from the atmosphere enters into the propellers, and this air is being subjected to the compressor, where the compressor works in order to increase the temperature and pressure of the inlet air which is being sucked from the atmosphere, and it is being subjected to the combustion chamber, where the combustion chamber helps us in producing the power, where the combustion process is carried out with respect to the fuel being ignited in the combustion chamber, and the power which is being developed in the combustion chamber is being subjected to the turbine, where the pressure is being reduced in the turbine, and the exhaust gases which is being released from the combustion chamber is being released from the turbine is being subjected to a higher velocity, that is a maximum speed to travel, so that the expansion process is carried out in the turbine, and after the turbine the exhaust gas which is reaches to the nozzle structure, where the nozzle structure there is a concave structure, that is convergent or divergent nozzle, where if a volume of the exhaust gas which is reaching from a maximum to a minimum diameter, there will be a higher velocity, so that the velocity of the air at the tip of the end of the nozzle will be higher, which leads to a better thrust of the aircraft, which leads to a higher velocity to the aircraft to move at a higher speed. Now, what is the working principle of the propulsion system is being tabulated with respect to the line diagram. Here, the fresh air is being subjected to the compressor, where the air which is being sucked from the inlet duct, that is from the atmospheric air which is being absorbed or which is being sucked inside the inlet chamber is being subjected to the compressor. The air which is being sucked by the propeller is in the way that should not go outside, or it should be used completely by the compressor, and rest of the air which is flowing which is being sucked inside with respect to the propeller is being subjected to the outer surface of the engine, which is being used for the thrust reversers as well. Here the fresh air is being sucked inside with respect to with the help of propellers, or with respect to the fan which is being provided or which is being connected to the main shaft of the engine, and it is being compressed in the compressor. Here the compressor helps us in increasing the temperature and pressure of the gas which is being absorbed, and it gives provides gas, or it provides air which at a higher temperature and pressure being subjected to the combustion chamber. Here the air which is being sucked from the inlet air is being compressed, and at a higher temperature and pressure it is being subjected to the combustion. Here in the combustion chamber, the air at a higher temperature and pressure is being subjected, and the fuel is being subjected in the combustion chamber, and it is being ignited at this combustion chamber, and the power is being emitted in the combustion chamber, so that the air at a higher velocity and a higher temperature is being subjected to the turbine. Here the initial, that is the sense, the expansion process, the initial expansion process is carried out in the turbine. Here at a air from the the fuel exhaust from the combustion chamber comes with a higher pressure and temperature, so that the pressure has to be decreased in order to get a better thrust, so that it is being subjected to the turbine. With the help of a turbine, it helps us in driving the compressor, so that the power which is being absorbed from the combustion chamber helps us in driving the turbine blades, and these turbine blades helps us driving the compressor which is being at the inlet section. After the air or a mass flow of the exhaust gas which has been coming out from the turbine, it is been subjected to the nozzle, where we can get a maximum thrust of the exhaust gas which is being subjected to the nozzle. Here the working of the air propulsion vehicle is carried out with respect to the Breton cycle. Here the working is carried out with respect to the principles of Breton cycle. Here with respect to the pressure and volume graph, the different cycles represents what are the conditions of the air which is being carried out, and what is the temperature drop and the pressure drop which is carried out at this area. With respect to the pressure and volume, we are just finding out at the lower values, that is here from the cycle from 1 to 2, here it is from the inlet to the combustion chamber. Here from the stage 1 to 2, here there is a gradual increase in the pressure, whereas in the sense here this does the process of the increase in the pressure and the temperature of the air which is being sucked from the atmosphere. Here the air is being increased at this area, and 2 to 3 there is a constant pressure is maintained at this area, whereas it is in the combustion chamber where will be where the burning of the fuel and the mass flow of the air is being carried out, and here the pressure is maintained at a constant temperature. After the combustion process, it has to be subjected to the exhaust. So the cycle from the 3 to 4, there should be a pressure drop at this area, so that a turbine is involved at this cycle, so that here the pressure of the exhaust gas which is being flowing out is being reduced at this area. Here the cycle from 3 to 4 represents a gradual decrease in the pressure of the airflow, and at the final stage of 4 to 1 there is a constant pressure is being maintained using the so that the air which is flowing and from the inlet to exhaust, how the pressure and the volume is being carried out from starting from the inlet to the exhaust system is works with respect to the PV diagram. And with respect to the temperature and entropy, we are just calculating how the temperature drop is carried out. Here from the stage 1 to 2 there is a constant temperature. There is not any increase in the temperature, so that the temperature is maintained at a constant level, whereas when it moves from 2 to 3 there is an increase in the temperature, where it is carried out at the compressor from the combustion chamber, where the compressor helps us in increasing the pressure and temperature of the gas which is being sucked inside, and at a 3 to 4 process where the constant temperature is maintained at this area, and from 4 to 1 cycle, here the temperature gradually decreases and comes to its initial state. Here you can get an idea about how the propulsion system works with respect to the pressure and temperature. The next one we are going to see about the line diagram of a turbofan engine. How actually the propulsion system work and what are the components which is being involved in a propulsion system, and each and everything how it works with respect to get a better efficiency will be discussed here. Now the first one is the inlet deck, that is here the fan or the propeller is situated, and after that it has been connected to a compressor which has been shown at this area. Then the compressor is being connected to the combustion chamber where the combustion process is carried out, and the it is been the power which is being exhausted is subjected to a turbine where the pressure of the exhaust gas is being reduced and it is being subjected to a higher velocity. Here this is the afterburner process, so that the air which is being exhausted from the turbine comes with a higher velocity of speed and with less pressure, so that at the afterburner process the air which is flowing inside the nacelle structure also is being subjected to the afterburner process, so that there will be a ignition system, so that the air which is coming, the air which is not subjected to the combustion chamber and the air which is coming out from the combustion chamber helps us in the burning process, in the afterburning process, and it leads to a better thrust at the nozzle structure which is being shown at the end of the actual aircraft engine. This is the nozzle structure where you can get, so that the volume at this area is being reduced at this area, so that you can get a better thrust at the nozzle structure. Each and everything here, the internal lip, in the sense here the fan or the propeller is subjected at this inlet lip, so that it has been subjected to the hub of the shaft which is being connected to the combustion chamber, so that if after the sucking or after the pulling of the air from the atmosphere, it has been subjected to the compressor where the compression of that is in the sense the temperature and the pressure of the inlet air is being increased and it is being subjected to the combustion chamber where the combustion process is to be carried out with respect to the mass flow rate which is required by the engine to get a better efficiency. Here in this will show what is the actual turbofan engine works and how it works with respect to the components. Then with respect to the propulsion system, what are the major factors or major things which we are going to consider? The major things, major system, propulsion system, major systems in the propulsion system is the types of engine and the propellers and with respect to the fuel system. We will be discussing one by one now. Now first we are going to discuss about what are the types of engine which is available in the propulsion system. Here 5 kinds of engine is being available now in the market, and many research works are being carried out with respect to increase the efficiency and a better thrust with respect to less drag. Here the first one we are going to discuss about the ramjet engine. Here the ramjet engine consists only of 3 components, that is in the sense the diffuser which is being kept at the inlet of the structure, so that the diffuser consists of many number of blades which sucks the air from the atmosphere, and this air is subjected directly to the combustion chamber, so that there is no compressors being involved at this inlet section, so that the mass flow rate of the air which has been sucked from the diffuser is subjected directly to the combustion chamber, and the fuel supply is supplied to the combustion chamber, and the mass flow of the air has been subjected to the combustion and the ignition, and it is being ignited and the power is being transmitted through the nozzle. Here at the end of the section there is a nozzle. Here it consists of the 3 parts, that is the diffuser and the burner, that is the combustion chamber, and the final one is the nozzle. Here it requires a high speed to efficiency to compress the air. So that this kind of ramjet engines are used in military purposes and naval purposes in order to as well as in missiles, so that we can get maximum efficiency or maximum force with respect to the inlet of the air which is being sucked inside. The next one we are going to discuss about the turbojet engine, which we have already seen. That in the sense here the turbojet engine consists of the inlet, the compressor, the combustion chamber, the turbine and the mixer, and finally is the nozzle. Here at the intake section it does not contain any propellers or any fans at the intake section. Here with respect to the air which is coming inside due to the force which is being force the aircraft which moves, the air which is being sucked inside is directly subjected to the compressor, and the compressor here helps us in increasing the pressure and temperature of the sucked air, the entire air which is coming inside the nasal structure, so that this mass flow rate of the air which has been sucked inside the nasal structure is entirely subjected to the combustion chamber, and the temperature and pressure of the air is being increased at this area, and this is subjected to the combustion chamber. With respect to the fuel supply, and the mass flow rate of the air which has been sucked is ignited, and the power is transmitted to the turbine, where we can reduce the pressure of the air which is being exposed from the combustion chamber, and the mixer, in the sense here some of the gases will be entering into the combustion chamber, and the exhaust will be released at this area, whereas most of the air which has been sucked inside the nasal structure are being subjected inside the nasal structure. Here the mixture area is area where the afterburner process is carried out. Here the gases which is coming out from the turbine, that is from the combustion chamber, and the air which is flowing inside the nasal structure get mixed up, and it is being ignited here. In order to get a better thrust, we are just using this kind of afterburner process. Usually this kind of turbojet engine are used in military purposes only. Here at the final there is a nozzle, so that here the purpose of a nozzle is to increase the velocity of the air in order to get a better thrust. Here compressor sucks the air and requires very high speed rotation, and is required to gain better efficiency. The next one we are going to see about the turbofan engine. Turbofan engine consists of a fan or propeller in the front of the nasal structure, which is being connected to the shaft of the combustion chamber. Here at the inlet section, it consists of a propeller which is connected to the hub of the shaft, which is being connected to the transmission system of the combustion chamber, so that the power is being transmitted from the inlet to the exhaust system. Here the fan is being subjected at the front, whereas here in turbojet the fan or propeller is not situated. Here the fan helps us major part of section of the air, so that maximum amount of mass flow rate. If we need a better efficiency in order to get a better thrust, we need to go for a propeller or a fan which has been subjected at the inlet of the nasal structure, so that we are going for a fan or a propeller at the inlet section which sucks a maximum mass flow rate of the air which has been sucked to the compressor, and it is being compressed, and the combustion process is carried out in the combustion chamber, and the exhaust gas is being subjected to the turbine, where the pressure of the exhaust gas is being reduced, and it is being subjected to a higher velocity. Then it has been subjected to the nozzle, so that the velocity of the exhaust gas releases at a very high speed, so that we will be getting a maximum thrust. Here the next we are going to see about the turbo propeller. Turbo propeller consists of a fan which consists of a maximum diameter with respect to the nasal structure. Here the fan is situated outside the nasal structure, which absorbs or which sucks the air entirely inside the nasal structure, so that only a smaller quantity of air has been subjected to the combustion chamber, and it has been used for the combustion process, and it has been subjected to the turbine, and the rest of the air which is flowing through is through over the surfaces of the nasal structure is used for thrust reversal processes. The thrust reversal process we will be discussing later. Now this turbo propeller helps us in finding out the maximum thrust. Will be just with respect to the Mach number, we are just calculating what is the angle of the propeller is used, and what is the diameter of the propeller which we have to use in order to get a better efficiency. The final one is the turbo shaft engine. This type of turbo shaft engine are usually equipped in helicopters, whereas this power has been transmitted through the shaft, and it helps us in lifting the aircraft engine. Here, this type of shaft, here the power has been subjected to the shaft, which helps us in lifting of the aircraft. The whole energy is used to power the shaft only. Here the propellers are used in a way such that it should absorb the air, or it should suck the air, and it is being transmitted to the shaft, which helps us in lifting purposes, and which with a lesser drag coefficient. Then what are the components which are being involved in the propulsion system, and what are the factors to be considered in order to design components in the propulsion system will be discussed now. The major parts which we are in research and development, as well as major part is going on in order to increase the efficiency of the aircraft, that is the propulsion system. Here, what are the things which will increase the efficiency of an aircraft with respect to the fuel system, and with respect to the air which is being sucked inside, and with respect to the mass flow rate, and with respect to the nozzle is being discussed here. Now, the first one we are just considering about the propeller. Propeller is nothing but a fan which is being kept at the front of the engine, which is being connected to the shaft, which is connected through a shaft to the combustion chamber, and the transmission system is carried out in order to supply the exhaust gas to the nozzle at a very high speed. Here, the diagrammatic representation of a propeller has been drawn here. This is the tip section where you can find out, and the leading edge, the trailing edge. This is the root area. This area is to be designed in a way so that we will be getting maximum absorption of air, which should not once entered, which should not go outside, is to be considered this area, and the hub which is to be connected at the shaft of the transmission system. Here, when the air enters into the propeller system at these areas, here once the air being sucked out with respect to the propulsion speed and with the diameter of the blade, here what are the considerations which we have to consider in order to design a propeller? Blades are made in a shape of an aerofoil structure, so that it should act as a wing in order to lift the component or lift the aircraft engine. It should be designed in a way it should satisfy airfoil structure, so that when air is being subjected, it may be a laminar or turbulent flow of a mass flow rate, so that it should satisfy a flow which is coming inside, should satisfy the airfoil structure, which leads to the component to lift. So that the main factor which we are going to consider about the thickness and the diameter of the propeller shape. The blade produces a lift, which is nothing but the thrust which is being calculated, and the main factor which we are going to calculate over the propeller is the helix angle. Here, the blades are designed in a way so that it will be forming a helix angle with respect to the another blade, so that only the air which is being sucked inside the propeller should not move outside. You should only suck the air, and it is being subjected to the compressor in order to maintain equivalence or balance of the aircraft engine. The propeller has to be designed with respect to the helix angle, and the angle between the resultant velocity and the relative velocity and the blade rotational direction is to be decided before considering before entering into the design of a propeller. Then these design consideration are to be calculated with respect to the efficiency which we require. Based on the efficiency only, we are just calculating what is the diameter of the fan and what are the thickness which we are using and what are the materials which is being used to produce the propeller. Usually, and the earlier days, they are the propeller is being made with respect to the hood, and now they are using composite material in order to reduce the weight, as well as in order to get a better efficiency, in order to get a better machining effect and the surfaces as well. Now, the propeller is carried out with efficiency of a propeller is carried out with respect to the efficiency. Design of a propeller is carried out with respect to the efficiency, where the efficiency of a propeller is with respect to the propulsive power out by the shaft powering. With respect to the propulsion power only, the shaft power is being used, and with respect to the efficiency only, we are just calculating what is the design and the shape of the propeller being used in an aircraft engine. The next major part is the compressor, where the pressure and the temperature of the inlet air is being increased and it is being subjected to the combustion chamber. So, the main factors in order to design the combustion chamber, in the sense each combustion chamber consists of many sectors, that in many stages of blades, many rows of blades. That is in the sense some of the blades may be rotational, that in the sense it may be a rotational type, and some other stationary type. Here in the compressor, the blades are to be in a, designed in a way so that it forms some helical angle, so that the air which is being absorbed from the propeller is to be sucked inside, and it is to be compressed at one stage, and it is to be subjected to the next stage with a higher pressure. Here the air enters into the compressor using enters into the compressor at this way, like the diagrammatic representation as here shown. Shown here. Here, the air from the propeller enters into the compressor with respect to the blades which is being designed in a shape that it should form a helix angle with respect to the blade, which will get a maximum power. And what is we have to consider about the rotational speed and dimension of the blades which are being placed inside the combustion chamber. There are a number of stages which is been involved in the combustion chamber with respect to the efficiency. Here also efficiency plays a major role, because efficiency with respect to in order to gain a better efficiency only, we are getting into better design and better performances. Here we have to consider about the air angle which is being entering into the combustion blades, whereas here it consists of two blade system, that is, it consists of a number of rows which consist of rotational blades and which consist of stationary blades. Here the profile of the rotational blades will be in the diagrammatic representation of the profile. Rotational blades will be in the shape of concave, which will be in the shape of this kind, and the stationary blade will be in the shape of this kind. So that the rotational blades helps us in absorbing the air which is being sucked, and it is being rotating the air which is being at this stage, and it is being subjected to the stationary blade, where the stationary blade helps us in changing the kinetic energy into a stagnated pressure. After this pressure is created, the pressure is once again subjected to the next stage, and the cycle process that in the sense the change of kinetic to the stagnated pressure and increasing the pressure and the temperature of the gas which is air which is being sucked by the compressor is being carried out using the different stages. The stages depends upon the aircraft which is being used, and based upon the power of the aircraft only the stages will be increased, and major factors which will be considered with respect to the air angle at each stages, and how the variations of the angle is to be carried out with respect to the tip of the propeller and with respect to the tip of the blade with respect to the root of the blade. Here compressor plays a role of compressing the air which is flowing inside, and it is increasing the pressure and the temperature of the air which is being coming, and it is being subjected to the combustion chamber. Here next is the combustion chamber, where the combustion chamber is to be designed in order to maintain a thermal protection, so that heat should not get dropped, so that the thermal protection is to be carried out in the combustion chamber. In order to get a better efficiency, it has to be made with a material which has to be highly resistant, as well as it should not there should not be any temperature drop or pressure drop over the combustion chamber. And after the combustion process is carried out, the air which is being the exhaust which is being coming out from the combustion chamber enters into the turbine. Here how the turbine blades will act with respect to the air which is being subjected from the exhaust gas. Here the turbine blades are in a shape of this. Here also the stator as well as the rotary blades are here, whereas the air enters at the turbine blades with respect to this direction, so that we will be finding out what is the rotational speed and the dimension of the turbine in order to reduce the pressure of the air which is being exposed from the combustion chamber. Here also we need to find out what is the air angle and what is the rotational of the speed and the dimension of the blade is to be maintained in order to reduce the pressure and in order to stagnate the pressure which is to be exposed to the nozzle is to be considered in the turbine section. The next one is the nozzle structure, which helps us in improving the thrust, so that the major area which covers with respect to the nozzle structure only. Here the nozzle structure, it is the final portion of the propulsion system. Here this nozzle design is with respect to the convergent or with respect to the divergent, or it has a combination of convergent and divergent nozzle as well. Here, what are the factors to be considered in order to design a better nozzle, in order to get a better thrust with respect to the power which is being produced? The major thing which we have to concentrate on the diameter of the inlet and the exhaust of the nozzle structure. This inlet of the nozzle structure is to be will be attached with respect to the outlet of the turbine structure, so that the expansion process is carried out. Here the air from the exhaust gases from the turbine enters into the nozzle, and here the volume is at a higher level, so that when it is moving to a smaller diameter of the exit of the nozzle, here the volume being reduced at this area, so that when the volume being decreased from a major to minor area, it is being subjected at a very higher velocity. So this is the area where we will be getting a maximum thrust, which will propel the propulsion system or aircraft in a forward direction. Here, many consideration has to be considered with respect to the nozzle structure, with respect to the material which is being used, and what are the things which we have to also consider in designing of nozzle is the gross thrust coefficient, which is nothing but the actual thrust with respect to the ideal thrust, and the discharge coefficient here at this area, which is nothing but the actual mass flow rate with respect to the ideal mass flow rate, and the throat diameter. This is the major factor we have to be considered, the velocity coefficient and the nozzle thrust coefficient. These are the main factors which we are to be considered in order to design the propulsion system, and we will be getting an idea what are the components being involved in the propulsion system, how the design is to be carried out, and what are the major factors which has to be carried out, and major design which has to be carried out in the propulsion system. The next one is a graphical representation of the key interfaces of the aircraft engine. Here, as we discussed earlier, each and every system is being discussed over here. Here, this is the aircraft engine where the propeller is situated at the outside the nacelle structure, so that the air which is being sucked from the atmosphere is subjected to the compressor at this area, whereas it may be a compressor where the pressure is being increased at this area, and it is being subjected to the combustion chamber which is kept at the inside the nacelle structure, and this combustion is carried out, and the combustion, the exhaust gases which is coming out from the combustion is subjected to the turbine at this area, and it is being subjected to the nozzle structure where we will be getting a maximum thrust at this area. Here, now we are going to discuss about what is the thrust reverse, how we will be creating a thrust reverse at this area, and how the mass flow rate helps us in decreasing the speed of an aircraft in order to reduce the speed of an aircraft at the landing time as well. Here, the working of the propulsion system. Here, the air is being sucked with respect to the propeller, which is being sucking, and it subjected only 30 or 40% of air. That is the mass flow rate of the air which is being sucked, and it is being subjected to the combustion chamber, and maximum amount of air is being subjected inside the nacelle structure, which helps us in afterburner process, or else at the time of landing we are in need to reduce the force, or in order to reduce the speed of an aircraft at lower landing areas, so that the thrust reverser is subjected at this area, where this air which is entering at this area can be used for thrust reversing processes. Here, the thrust reverser helps us in blocking the air which is coming inside, so that if we open the cowl at the nacelle structure at this area, this helps us in deviating the air which is flowing to the exhaust to at this area. The air will be deviated, so that at this area you will be getting the thrust reverser, so that we will be reducing the speed of an aircraft. Here, the thrust reverser is carried out with respect to manually in the sense mechanically, or with the hydraulic or pneumatic system. This thrust reverser process structure can be accommodated with respect to the nacelle structure which is already been designed. The next one we are going to see about the fuel storage system, which is being involved in the propulsion system. Fuel storage system. Here, fuel storage system in aircraft engine is being employed, and the fuel tank is being employed at the wing of an aircraft engine. Here, from the wing, it is been subjected to the engine with different kinds of pipelines, and wherever the fuel requirement is there, there will be a pipeline subjected with respect to, and it is being pumped with respect to different pumps and hydraulic and pneumatic system, so that there will be different blocks will be placed, or different controls or valves will be controlling the fuel system in order to supply the fuel to the aircraft. Here, usually the fuel system, the fuel tank is situated in the wing, and from the fuel tank, the fuel is supplied to the engine, that is to the combustion chamber, where the nacelle structure contains the the tank above the combustion chamber, so that the combustion chamber where the combustion process is carried out with respect to the fuel which is being subjected over here. With respect to the fuel system which is being involved in the propulsion system, here many factors has to be considered in order to prevent the fire, and in order to maintain the temperature and the flow of fuel is being subjected to the aircraft engine or aircraft plane itself. So we will be discussing what are the fire precautions and what are the methods will be involved in order to maintain the flow of the fuel. The next one we are going to use about the sensing, which is being used in finding out what is the volume available of the fuel in the fuel tank. Here many types of sensors are used, and the major kind of sensors are majorly the sensor which are used to find out the level and the pressure drop or some other purposes, or the electromagnetic sensors and the magneto-resistance sensor. These kinds of sensors helps us in finding out what is the level of the fuel in the fuel tank, as well as what is the temperature which is being maintained at the fuel tank, so that the continuous flow of the fluid is to be subjected to the different parts of the aircraft, so that at the temperature, when the temperature is lesser, it has to be maintained continuous flow of fluid, so that the fuel should not get solidized, so that the temperature will be maintained over the fuel tank, as well as it should not go above the temperature of the fuel, so that some of the sensors are being used in order to maintain the volume, as well as finding out what is the thermal activities and what are the flow and how to control the flow. Everything is been sensed and it is been subjected to the cockpit. The next one we are going to see is about the operability. Operability is nothing but what are the actions which will be carried out in a propulsion system, or with respect to the aircraft, entire aeroplane or a commercial aircraft. What are the operations will be carried out with respect to the design, or with respect to the purpose it has to be, it is being designed, will be carried will be studied in the operability. It is easy to operate anywhere in the propulsion system as well as the aircraft, and most of the components are being used and operated with respect to the commands which is being subjected from the cockpit only. Here, one of the operability which we are going to see is now the cowl which is present, cowl structure, that is in the sense in a nacelle structure there is a cowl at the engine which covers the engine part of the propulsion system, where if some repairs occurs at the engine part, we are not subjected to entirely remove the nacelle structure and finding out what is the fault in the engine system. So we can just lift the cowl at the nacelle structure and can rectify what is the fault which is occurred at the engine system. So this cowl can be lifted in a way so that it has been used with respect to, it has been operated with respect to the hydraulic or pneumatic system. Like that, many of the operations will be carried out with respect to the operability of the commands which is being carried out from the cockpit, that in cockpit of the aircraft engine. Then the final thing is the installed performances. Installed performances is that is nothing but starting from a raw material to the finished product. We are just creating each and every part for the propulsion system and aircraft engine, and we are just finding out what is the actual actual process which is going on in the system, and what is the structural stresses which is been acting over the structure of an aircraft engine is being calculated in installed performances. Installed performances in the sense each and every part is been designed and been manufactured, and at the final stage it has been subjected to the analysis with respect to the structural analysis. Not only in the final stages, starting from each and every stages they have been subjected to structural as well as the fluid dynamic analysis as well. Here analysis part is carried out at every section. At the final section, after the whole assembly has been created, it has been subjected to the computational fluid dynamics, that in the sense when the aircraft is subjected to the atmosphere, and what are the actual process and what are the actual effects it will cause when it is subjected to the atmosphere can be found out with respect to the software which is available in the market now, and this can be what, and this will give a better idea about what is the actual stresses or what are the thermal conditions which is carried out inside the nacelle structure, and what are the thermal and the process which is carried out on the structure of the aircraft engine with respect to the aerodynamic forces and with respect to the shock forces, and these and all will be calculated with respect to CFD analysis, and this will be tabulated and finding out a better solution in order to get a better efficiency of the aircraft. Next one, we are going to see about the propulsion system control. Here the propulsion system consists of many controlling system with respect to the hydraulic and the pneumatic systems. Here the hydraulic system and the pneumatic system. Hydraulic system helps us in operating or moving a part with respect to the fluid, that is with respect to the fluid, whereas the pneumatic system is being used with respect to the air which is been subjected, the compressed air which is been subjected in order to do the motion of the system. Most of the propulsion system is carried out with respect to the hydraulic and pneumatic system as well. Then now we are going to see about the thermal protection which is being involved in the propulsion system. The thermal protection system is the major work which is to be carried out in the propulsion system, because here the combustion process is carried out so that there will be more dissipation, distribution of temperature increase, as well as there will be a less pressure drop, so that how this temperature is to be maintained, and in order to be safer mode, what are the thermal protective shield should be enclosed in a propulsion system is being studied under thermal protection system. This protection is used to avoid the effect due to the overheat and the heat temperature in the engine. Here at the combustion chamber, the air which is being subjected to the combustion chamber, and the combustion is carried out with respect to very high temperature, so that this temperature should not affect the other parts and the nacelle structure, so that the temperature is to be maintained in a way so that it should not affect the external parts of the nacelle structure or the external parts of the engine, which leads to the reduction of the efficiency. So major major work is carried out in the thermal protection as well. Now some of the thermal protective shields which is to be involved in the propulsion system is the first one is the composite to perforated metallic substrate. Here this composite, the material is to be manufactured in the way so that it should be a composite material, it should be which should withstand very high temperature. That is the first one, or it should be coated with some of the composite material. Then the next one is the perforated metallic skin of aircraft cooled by a circulating fluid. In order to reduce the temperature of the higher temperature which has been produced at the areas where we will be finding a maximum temperature, it should be subjected to some cooling processes or cooling tubes with respect to the flow of liquids, which will reduce the temperature over these areas. The next one is the thermal barriers coating for interior surface of the perforated metallic panel. Here the representation of the three factors of the thermal protection shield is been represented, and what are the uses of these protector with respect to maintain the temperature is being discussed now. The next one we are going to see about the fire prevention method, and which is been involved in the aircraft propulsion system. The main areas that affects and start fire are areas in the aircraft engine is nothing but the engine axis structure, where we will be getting fire, will be exposed to a fire due to the air which has been coming inside the nacelle structure, as well as the temperature of the exhaust gas which is being released, so that the fire will be carried out at the nacelle structure, or it has been otherwise called as engine bay. And another part where we will be getting fire is in the dry base, that is the ignition zone, which has been shown here. Whereas here at this area the temperature will be more, so that there may be a chance to create fire with respect to the gases which is being exposed. Then the next one is the vapor space, where above the liquid fuel in the tank. These are the major areas where you will be getting the chance to ignite a fire in the aircraft engine. So what are the prevention methods we have to follow in order to maintain the temperature in order to get a chance not to get a fire, or if a fire is being catched out, what are the prevention methods we have to do in order to control the flow of fuel, and how we can reduce or we can control the fire with respect to any aircraft will be discussing now. The methods of fire protection is being discussed with the three major topics, that is prevent, alert and control. Here, how we can prevent the fire in an aircraft propulsion system. Here the first one is the fire arrestor. It is a plastic thick foam to prevent the dry bay fire. A plastic thick foam is being coated over the engine part, so that if any chance to get a fire, it will not supply the fire to the external parts of the engine as well. Then the next one is the self-scaling material. Self-scaling material in the sense, if any chance of getting a fire, this automatically scales and swells in the inner walls carry the swells and seals that holds when exposed to the fire. That is in the sense, if there is a chance of getting a fire, then this helps us automatically in putting off the fire at this prevention method. Here, what are the alerts will be carried out in order if fire is being carried out, if the fire is being created. The alerting techniques, there are the alerting techniques which with respect to the sensors and with respect to the flow, which are what are the alerts which has to be given to the cockpit, who will be controlling the flow of the fuel, as well as in order to reduce the fire which is being already put on. The first one is the electric resistant wire, which find out what is the heat which has been created, and what are the this resistor wire which subjects message to the cockpit, which will which gets a command to stop the fuel control from the cockpit. The next one is the sensor. Sensor plays a major role in controlling the fuel, as well as maintaining the temperature of the fuel system or the temperature of the surfaces which covers the engine part as well. Sensors senses the temperature and the fire areas where it has been exposed, and this sends the information to the cockpit, where they can control the fire by stopping the walls of the fuel flow. The next one is the detector, which detects the fire and it alerts the persons who are sitting in the cockpit, and they command the system in order to reduce the fire. And what are the controls which are used in the fire prevention system is being discussing. We will be discussing now. The first control which we will be discussing now is the automatic shut off and the firewall. The next one is the firewall, and the final one is the fire extinguisher. The first one is the automatic shut off. If the fire is being exposed and it is not able to, it in the sense the fire has been already shut on. What are the methods in order to control the fire in an aircraft? Here, you might have seen in many commercial buildings and in aircraft engine, aircraft as well as in trains. If fire is being exposed, you will be finding out spray over the top, so that it will spray the liquid over the fire, or a fire extinguisher, which helps us in controlling the fire at the area. So that this is the automatic shut off, which helps us in controlling the fire at the area. The next one is the firewall, which helps us in blocking the fuel system at different levels, at different walls, at different sections of the aircraft in the aircraft propulsion system. These are the major fire protection system and how they are being prevented, and how they alert the person in order to the fire, and how this fire is to be controlled with respect to the fuel system. Fuel system is being discussed, which we have discussed now. This is the diagrammatic representation of a fuel system which is being available in the aircraft engine, that is in the sense aircraft. Here the fuel tank, here it is a fuel tank. From the fuel tank, with the help of a pump, it has been subjected to different portions of the aircraft, so that at many the fuel from the tank that is situated in the wing is being subjected to the engines, so that it will pump with different pipeline to the engine in order to give the fuel to the combustion chamber. Here there are many pumps which is being involved in the fuel system in order to give supply to the combustion chamber. This is being here the combustion is carried out, and it is being exhaust at this area, that is the nozzle structure. This is the diagrammatic representation of fuel system which is carried out in the aircraft. The next one we are going to discuss about the auxiliary power unit. What is auxiliary power unit actually? Auxiliary power unit is external power which is used to run the propeller of an aircraft, as well as it gives external power to the electric power which are to be used in an aircraft with respect to the external powers. Here it provides a power to start the engine. The auxiliary power unit provides a power to start an engine, and it also provides power to the electrically and the pneumatic and hydraulic system as well. Then it is operated by means of battery, hydraulics, hydraulic accumulator as well. Here the graphical representation of actual auxiliary power unit is shown at this area, so that the fuel is supplied and the auxiliary power fuel shut off valve are being provided at different stages. And if the this is the part where the auxiliary power unit door is being used, and here the jet engine is being situated at this area, whereas the auxiliary power unit helps us in supplying the power to the engine with respect to the fuel control units and the APU coolings and the fire actuators and the accessory drives. Here auxiliary power unit helps us in transmitting the power from the end portion of the aircraft to the engine part, so that it transmit the power from one portion to another. With respect to the auxiliary power unit, it supplies electrical power to start the engine. After starting only we will be getting the thrust, we will be creating the thrust of an aircraft engine. So auxiliary power unit plays a vital role in starting the engine, and it provides the electrical supply to the entire aircraft itself. Now we will be discussing briefly about what is the auxiliary power unit and how the structural interface of the auxiliary power unit will be actually used in an aircraft engine. Auxiliary power unit is a device on a vehicle that provides energy for functions other than the propellers. It provides an external force or external energy in order to run or start the propeller of the engine. Here, they produces 105 watts to 400 hertz to run the electrical system of an aircraft. Usually, this helps us in transmitting the power with respect to the hydraulic and pneumatic system as well. They can provide a through signal. They can be provided with respect to two-phase or with respect to three-phase system as well. Three-phase system. They provide power to start the engine. Then, what are the components which is being involved in the auxiliary power unit, and what are the structural interface of the auxiliary power unit is shown in the representation of an aircraft. Here, usually the auxiliary power unit is situated at the end, that is in the tail of an aircraft engine. From here, it supplies the power supply to different part of an aircraft. Here, the supply is being carried out at different parts. Here, the supply, the transmission system is being transmitted to the engine, where in order to, with the help of the electrical power, it helps us in starting the propeller, that is in the fan of the engine, so that we will be there after the compressor and the combustion, and every thrust process will be carried out at this area. Here, what are the components involved in the auxiliary power unit, in the sense the generator, oil filter, the fuel filter, the fuel nozzle, and the bleed air valve, start motor, and the bleed air manifold, and the exhaust manifold. These are the components which are actually be in an aircraft with respect to the auxiliary power unit. From the auxiliary power unit, they subject the power to the different parts of the aircraft, and with respect to the command which is being subjected from the cockpit. Here, the diagrammatic representation of auxiliary power unit is here. Different lanes are being conducted so that the power is being transmitted to different areas for different purposes, and major power is being subjected to start the engine as well. With this, you might have got an idea about what is the propulsion system and what are the components which is being used in a propulsion system, how we have to design the component in order to increase the efficiency of an aircraft, and what are the design consideration we have to consider with respect to the fire protection. You will be getting a better idea with respect to my presentation. Thank you.